Okay, this one says find all exact solutions. And notice that it does not say find all exact solutions between 0 and 2 pi. Right? We deal with this kind of problem a little bit differently at the end. Right? We have the advantage in this problem that it's actually already in factored form equals 0. So we don't have to do, there's no substitutions to make it all in terms of the same trig function. There's no factoring to do. We can go immediately to cosine of 2x equals 0, or 2 cosine x plus 1 equals 0. And let's deal with the second one first, because I can see this first one's going to involve a multiple angle. Right? For this one, 2 cosine x plus 1 equals 0, subtract 1, divide by 2, cosine x equals negative 1/2. Okay, on the unit circle, I know that the negative 1/2 is here and here, which is 2 pi over 3 and 4 pi over 3. Okay, but because I'm solving this and there's no limit to the domain, I can't just say 2 pi over 3 and 4 pi over 3. I have to say x equals 2 pi over 3 plus 2 pi times n, where n is an integer. Meaning that if 2 pi over 3 solves this, if I add 2 pi, I get back to the same angle, and therefore it also solves it. And I could do that again and again and again. I could even take away 2 pi as many times as I want, and I get back to an angle which would also solve this. So I need this statement, and then I need to do the same thing for the 4 pi over 3. 4 pi over 3 plus 2 pi times n, right? 2 pi is the period of the cosine function. Okay, this is a multiple angle. And remember, we deal with this differently. Here's what we don't do, which many students did on the quiz, is you try to divide this by 2. You cannot divide this by 2, right? You cannot divide 2 inside the trig function. What you can do is you could say, well, I know cosine equals 0 at pi over 2. That means 2x, when 2x equals pi over 2, right, this is going to be solved. Now, even though the cosine has a period of 2 pi, in fact, cosine equals 0, if I look on the unit circle, and I'm going to use this one that's already here, cosine equals 0 at pi over 2, but it also equals at 3 pi over 2, and it also is 5 pi over 2 and 7 pi over 2. It's not repeating itself every 2 pi. It's actually repeating itself every halfway around the circle, which we know is pi. So we would have to say that 2x, the angle inside the cosine function, has to equal pi over 2 plus n pi. Not 2 pi times n, but just pi times n. Okay, now we're not done solving because we don't have this x isolated. I still need to divide both sides here by 2. And when I do, I get x equals pi over 4 plus n pi over 2. Right? And that will find all the solutions that when I plug them into here, it makes this cosine equal 0.